ask you to interpret the slope. Here's what, I want you to write it for this example.
Brandon, wait.
I turned it off and turned it back on again.
Alright, give me back one. You know, part two?
Yeah.
Part two. Alright, so we're identifying how to talk about slope in words. That's the word interpret that they always throw at us, and we never know exactly what they're asking for. So, what we want to say for this one is the slope is the decrease, a decrease, because it's negative, a decrease of 0.00344, what are we doing in calories? No, that would be the Y part, so it's not calories. Fat gain. A decrease of 0.00344 fat gain for every calorie increase. And that is every 1 calorie increase. Where's the 1 come from in this slope? It's sitting right there. Remember how we do rise over run? So we have to remember the rise is whatever's on the y-axis. That's where I got wrong initially, and I corrected it. So for a decrease of 0.00344 fat gain, a decrease of 0.00344 fat gain for every 1, there's the 1, calorie increase. So that's what that is in words. How about the y-intercept? What is the y-intercept, Allie?
Where the line hits the y-axis.
Right, and so what is the particular number in this equation?
3.5.
All right, so here's the y-intercept. Can you interpret that in this scenario, anyone? What would that mean? They drew a picture below they had put in the y-axis, so you can see clearly where it crosses. And if you go over to the y-axis from that crossing point, you'll see it is around 3.5. So it does make sense, but what does it mean? What's happening at 0 on this axis here?
The
non-exercise
activity is at 0.
Right, so there is no non-exercise activity, and if that was the case, if someone didn't fidget, or didn't move around, or didn't have body functions, what would their weight gain be after being overfed for 8 weeks?
How do they have negative non-exercise activities?
What?
How do they have negative non-exercise activities?
Right, so like just because the line is extended over there, it doesn't mean it applies to the situation. Right.
There's points.
Oh, they do have points over there.
Yeah.
Negative non-exercise activity. Oh yeah, I see them up in the chart. Oh, it's change. Not every change.
So they do less
Yeah.
than they
They
used
do
to.
less.
So
All right,
they
that's a
just
good
fidget
point.
less.
All right. So there's always an answer. Good answer to these questions.
Good answer. Is there a wrong answer to these questions?
These could have.
The awkward, like
All right,
when
let's
they
go over
say
to the
something
back.
like really
The
wrong,
regression
everyone's
line is
silent, and then they just start
repeated on the
clapping
back.
for themselves.
The whole reason we put in these lines like this is to predict values. So make a note of that.
More like family crew.
The purpose of regression lines. The purpose of regression lines is to predict. Because we don't have a point for every scenario, but once we put that line in, we have an infinite number of scenarios. So let's take, for example, when non-exercise activity is 400. We don't have a dot for that. It wasn't in the chart. So we can use this like a regression line to predict the amount of fat gain if your non-exercise activity calories was 400. So what was the fat gain at that point about? What's it look like, Julia, on the chart when you go up 400 and hit the curve or hit the straight line and go across?
A little over 2.
Right, 2 point something. Let's find out exactly by using this equation. So, Caleb, what would I do with the number 400 in this equation to find that she says a little over 2, but I need to know the exact number? So what would I do with the 400 in this equation? That gain equals this minus this times change in NEA. So, and I'm looking at a change of NEA of positive 400. So how would I?
So you put that in as X
Right, so you're gonna put a 400 in here.
and multiply
So,
that by.
alright, calculators out, put the 400 in there.
I got 2.12.
Alright, you were right.
2.129, so 2.13.
2.13, and that's kilograms.
So 129.
Alright, so if you were in this category of NEA of 400 calories, you would only gain 2.13 kilograms. Alright, and a kilogram's a little over 2 pounds, so, alright. So,
What?
notice what you told me, 2.13 is an expected value. That's why we put this hat on.
You
It's
never
an
know with
expected
me.
hat, so.
Wait, didn't that mean something different in algebra? The hat?
Oh, there, Y hat, what was the Y hat?
Is I hat and J hat?
What was that?
I hat and
Wait,
J
what
hat.
were you plugging the 400?
Yeah, that's what it was.
The
I hat and J
NEA
hat.
change.
So it's just another way to do
But she
rectangular
put
coordinates,
parentheses
I
around
and
it.
J, instead of,
Why?
I guess that's
400.
about it.
Why?
Yeah,
Can I use the
Because
yes
that's
you
the
may,
X
could you
value.
sign out, please?
Yeah.
Alright,
And we're
let's
trying to
check your
find it.
understanding, try another
just trying to find
scenario. This time we're talking about a
Yeah.
rat,
Back
we're
in
not
400.
trying to
Yeah.
kill this rat, we're actually watching him grow.
Oh
So,
yay, we're not.
alright,
sure
we're
yet.
not feeding him
Why couldn't we
bacteria or
save the guinea
anything.
pig?
What? Oh
Why
yeah.
couldn't we have just done it with the guinea
I
pig?
know. Alright, so can you find the equation? It's in the blab there, the first paragraph. Can you
Wait.
circle the equation where it says weight hat? Do you see weight hat?
Uh-huh.
Equals 100 plus 40 times time. So we're answering those 4 questions, so go ahead and answer those. I'll interrupt in a minute. You're finding the slope, and you don't even have to see the equation. And, you don't have to see the line, the scatter plot, all you have to see is the equation to find the slope. Find the slope, and then you're supposed to interpret it. Here's how I interpreted this one, so use something similar to interpret that one.
Or you want to write it and not say it out loud?
I'm sorry?
You just want to write it and not say it out loud?
Yeah, you at least take quick notes on it, it's sort of a study guide.
What is that sound?
Find the slope, write out what it means, find the Y-intercept, write out what it means. Predict the weight at 16 weeks and predict the weight at 2 years.
How many weeks are in a year?
52.
I feel like that was on in algebra. We asked it every single time.
What did you say? How many weeks are in it?
Mhm.
Oh, okay.
Remember that? I think that was an extra credit question in algebra because none of us knew it.
Yeah. Except
I didn't.
those other weeks.
How much does a rat normally weigh?
Not 9 pounds. right, we'll talk about number 4, because it's a special case we need to take a note on.
So they don't weigh 9 pounds.
No, they don't.
Okay.
I mean,
You
yeah, they
always
don't.
hear
They
about
don't.
they do, like they're as big as
They're-
dogs.
yeah,
but I
there
don't
can be
think
some
so.
They
that
don't like
I
continuously
think
grow
about
at the
this
same
is-
rate throughout their
That's true.
entire lifespan.
Just like people don't.
All right, number 1, what was the
Right.
slope?
What if we just kept growing
Allie,
at
what
the
was
same
the
rate throughout our
slope?
entire
40.
lives?
All right, the slope is 40.
Old people were
And what is
super
that?
tall.
How can you say that in words?
I said that there was an increase of 40 for every one weight per 40 year time.
It's
Weeks.
it's an increase for 40 per unit of time, and what that was in this case was a week.
Yeah.
So in words, the weight goes up 40 grams each week. That's how you can say that. Very good. So on part B, Bailey, what is the Y-intercept?
I said at 0 weeks since birth they weigh 100 grams.
Right, so at birth, that's their weight. All right, Julia, were you able to plug in 16 yet?
I plugged in the 16.
And what did you get?
I got 740.
740 grams. All right, something wacky happens though on number 4. So, Caleb, what happens when you put in 2 years? So that's 52 times 2. So it's 104 weeks. What answer comes out?
4,260?
All right, 4,260 grams. What that is called is not dependable results. If you change that to pounds, that is going to be about a 9-pound rat. That's like a newborn human being. So we do not expect rats to get that big. So what happened? What went wrong in number 4? Why did our statistics let us down?
Rats don't keep growing at the same rate.
Yeah. What happens is we are only allowed to use values on the explanatory, from the explanatory axis as high as our data goes. So in this one, the data only went up for the first 25 weeks. So anything after that, how do we know what happens? It might not be a linear pattern anymore. Like you said, the growth might stop. It'll definitely slow. So the data is going to change. And what that has a name, if you do that, if you go out beyond the boundaries of your explanatory data, that is called extrapolation. Extrapolation. So somewhere around number 4, make a note that that is called extrapolation. That is for values, I'll say far outside. If it goes a little bit outside the x values, that's okay. But if it's far outside the x, if we stopped at 25, yeah, here we are plugging in a, what was it, a 104? So extrapolation, that is for values far outside the explanatory range of values. So that is unreliable. Extrapolation is unreliable results. So let's use some time to get some work done and see if we can, how far we can get. Our assignment today is we're going to pull, we skipped several yesterday. The only one I really was interested in is number 26. So we're going to pull 26 down from day 2 and do 26. 27, 32 through 32 are just multiple choice, so they will go quickly. And there isn't a whole lot, 35, 37, 39, and 41 to do on those as well. It's not like a lot of graphing and so forth. Tomorrow we'll, you know what, I don't know if we can, I think we have to do it now actually.
Should I start and stop it again?
I think I do have to tell him something, so, there's a